Hello and welcome back. Continuing with the series, this is your host Harshit Sinha, again with a new topic on e-waste or electronic waste, which refers to discarded electrical or electronic devices. With the rapid pace of technological advancement and increasing consumer demand for newer electronics, the amount of e-waste generated has surged globally. With its massive population and growing digitalization, India faces a significant e-waste management challenge. According to recent reports, India is one of the largest producers of e-waste globally, generating millions of metric tons each year. E-waste poses serious environmental and health risks if not managed properly due to the presence of hazardous materials like lead, mercury, cadmium, and other toxic substances. Despite India's efforts to address e-waste through various regulations and initiatives, the country continues to struggle with inadequate e-waste recycling and disposal mechanisms. The informal sector plays a major role in handling e-waste, but its practices often lack the necessary safeguards to prevent environmental contamination and health risks. This note explores the current status of e-waste management in India, quantifies the types of e-waste generated, and examines the challenges the country faces in dealing with e-waste, including the way forward. The current presentation explores the types of e-waste produced, quantifies the scale of the problem, and examines the challenges faced by the nation in managing this growing environmental concern. Our journey will take us through the present scenario and look ahead to the issues India may face up to 2020. India has emerged as third largest generators of electronic waste globally after USA and China, with significant annual growth in e-waste production. According to the Global E-Waste Monitor 2020, India generated approximately 3.2 million tons of e-waste, which has been growing at a compound annual growth rate of about 31.6%. Based on current trends and projections by the ASSOCHAM EY study, India's e-waste generation is expected to reach 20 lakh tons in 2024, with projected annual growth rates ranging from 35 to 40%. While India has implemented recent e-waste management rules 2022, after amended in 2018, only about 5% of e-waste is recycled through formal channels. The majority is handled by informal sector workers, raising environmental and health concerns. Cities like Mumbai, Delhi, NCR, Bengaluru, Chennai, and Kolkata generate the highest volumes of e-waste. The composition of e-waste in India reflects its technological landscape. Computers and mobile devices dominate, followed by home appliances and consumer electronics. This breakdown is crucial for tailoring recycling and management strategies to handle different types of e-waste effectively. Based on current trends and projections by the ASSOCHAM EY study, major contributors to e-waste are computer equipment contributing 70%, mobile phones 12%, electrical equipment 8%, medical devices 7%, and other electronics device contributes to nearly 3%. E-waste encompasses a wide range of discarded electronic and electrical devices. In India, the primary sources include households, businesses, and the IT sector. Understanding these sources is crucial for developing effective management strategies. E-waste is composed of various materials with differing properties and hazards. Key components include 1. Non-ferrous metals. These make up around 13% of e-waste and include valuable but hazardous elements such as copper, aluminium, and lead. For example, printed circuit boards often contain lead and beryllium, which can be toxic if improperly handled. 2. Ferrous metals. Accounting for about 20%, ferrous metals like iron and steel are used in structural components of electronic devices. Although not inherently toxic, their recycling process can generate harmful residues. 3. Plastics. Representing 21%, plastics are primarily used in casings and insulation. They often contain brominated flame retardants and polyvinyl chloride, PVC, which release toxic dioxins and furans when burned. 4. Glass. Approximately 6% of e-waste consists of glass, especially from cathode ray tubes, CRT. CRT glass contains lead and other heavy metals, posing disposal challenges. 5. Toxic chemicals. These include mercury in fluorescent lamps, cadmium in batteries and circuit boards, hexavalent chromium used for corrosion protection, and arsenic in semiconductors. These substances pose significant health and environmental risks if not properly managed. These toxic substances pose serious environmental risks when e-waste is improperly disposed of or recycled. Improper e-waste management poses severe environmental and health risks. The release of toxic substances like lead, mercury, and cadmium contaminates soil, water, and air. Workers in the informal recycling sector, often without protective gear, are particularly vulnerable to health issues ranging from respiratory problems to cancer. Air pollution occurs when e-waste, such as circuit boards and plastics, is incinerated, emitting harmful gases like dioxins and furans, which are highly toxic to humans and the environment. Water pollution arises from e-waste dumping, where heavy metals like mercury, lead, and cadmium leach into water bodies, contaminating drinking water sources. This contamination affects aquatic ecosystems and human health, potentially causing neurological, reproductive, and developmental issues. Soil contamination occurs when e-waste is discarded in landfills, allowing toxic substances to seep into the ground, affecting agricultural productivity and entering the food chain. Health hazards are widespread, especially for informal sector workers in e-waste recycling, who are exposed to toxic fumes and chemicals. Conditions such as respiratory issues, skin disorders, kidney damage, and developmental problems in children are commonly reported. Communities near e-waste recycling sites also face increased cancer risks due to prolonged exposure to hazardous substances. Addressing these impacts requires stricter regulations, formal recycling initiatives, and raising awareness about the dangers of improper e-waste handling. The stark contrast between formal and informal e-waste management sectors in India presents a significant challenge. While the informal sector provides livelihoods to many, its practices often lead to severe environmental and health hazards. Bridging this gap is crucial for sustainable e-waste management. The formal sector in e-waste management comprises regulated entities that operate under government norms and utilize advanced recycling technologies. These entities ensure environmental safety through proper disposal mechanisms, adhering to rules set by regulatory bodies. The formal sector focuses on minimizing health risks, pollution, and resource wastage. However, it currently handles only about 5% of India's total e-waste due to high operational costs and limited infrastructure. In contrast, the informal sector is unregulated and manages nearly 95% of e-waste. It relies on manual recycling methods like acid leaching and open burning to extract metals. While these methods are cost-effective, they result in serious environmental and health hazards, including air, water, and soil pollution. Informal recycling exposes workers to toxic chemicals such as lead, mercury, and cadmium, leading to respiratory issues, neurological disorders, and cancer risks. The informal sector thrives due to its low-cost processes and lack of awareness among consumers regarding proper disposal methods. However, the absence of safety standards and environmentally sound techniques exacerbates its impact. Efforts to integrate the informal sector into formal recycling systems could help improve e-waste management. Establishing extended producer responsibility, EPR programs, and enhancing awareness are vital steps toward sustainability. The evolution of e-waste management rules in India reflects the country's growing recognition of the need to address electronic waste in an environmentally sound manner. Here's a brief overview of its journey. India has progressively strengthened its e-waste management regulations. The latest rules focus on the entire life cycle of electronic products, from design to disposal. However, implementation and enforcement remain significant challenges. The legal framework for e-waste management in India has evolved significantly over the years to address the growing challenges of e-waste disposal and recycling. 1. Early years. Pre-2011 year, that is before formal regulations, e-waste management in India relied heavily on informal recycling, which often involved hazardous practices with serious environmental and health consequences. The growing volume of e-waste due to rapid digitization and urbanization made regulatory intervention necessary, while later in 2011, the e-waste management and handling rules was introduced by the Ministry of Environment, Forest and Climate Change under the Environment Protection Act 1986. These rules aim to streamline e-waste collection, storage, transportation, and recycling. A key feature was the introduction of Extended Producer Responsibility, EPR, requiring manufacturers to take responsibility for managing their products at the end of their life cycle. 2. E-waste management. Rules 2016. These rules expanded the EPR framework by requiring producers to implement take-back systems and collection centers. They included producer responsibility organizations, PROs, to facilitate e-waste management and set recycling targets. Further continuing, the 2016 rules replaced the earlier framework to address emerging challenges. Key updates included compulsory EPR registration with the Central Pollution Control Board, CPCB, targets for e-waste collection by producers based on their market share and inclusion of bulk consumers, refurbishers, and dismantlers within its scope. 3. Amendment Rules 2018. These amendments refined the EPR mechanism, introducing revised targets for e-waste collection, 70% over 7 years. A penalty framework was implemented to ensure compliance, or one can say stricter collection targets were introduced, emphasizing phased compliance to achieve 70% e-waste collection by 2023. E-waste Management Rules 2022, effective from April 2023, the updated rules aim to digitize the e-waste ecosystem by introducing a centralized EPR portal. They emphasize mandatory registration of stakeholders and eliminating PROs, thereby placing the onus on formal recyclers for compliance. Overall, one can say that the rules focused on formalizing the recycling sector and implementing a digital EPR framework with traceability using technology, ensuring better accountability and transparency. India's efforts to standardize e-waste management have improved transparency and accountability, but challenges persist due to the informal sector's dominance. India's e-waste management rules are evolving towards achieving a circular economy. Extended Producer Responsibility, EPR, is a key policy approach in India's e-waste management strategy. It shifts the responsibility of end-of-life product management to the manufacturers. While EPR has shown promise, its implementation faces challenges due to the complexity of the electronic supply chain and the informal sector's dominance. Extended Producer Responsibility, EPR, is a critical policy tool that holds manufacturers, producers, and importers responsible for managing their products' end-of-life impacts. Under EPR, entities are required to meet collection targets for waste products, such as plastics or e-waste, ensuring proper recycling and disposal. These collection targets are often quantified and time-bound to encourage efficient recovery and recycling. For instance, India's 2022 e-waste management rules mandate specific annual recovery rates for producers, increasing progressively over time to promote accountability and compliance. Additionally, EPR focuses on awareness creation to educate consumers about proper waste disposal, enhancing participation in recycling programs. Producers also work on eco-design principles, incorporating sustainable materials and reducing the environmental footprint of their products by making them easier to recycle. The framework further requires the development of recycling infrastructure, including formal take-back systems and partnerships with recycling facilities. This reduces dependency on the informal sector and ensures environmentally sound recycling processes. EPR drives a circular economy, incentivizing businesses to reduce waste generation while improving resource efficiency. It not only mitigates environmental pollution, but also creates employment opportunities in the recycling and waste management sectors. India faces multiple challenges in effectively managing its e-waste. The lack of public awareness about proper disposal methods, combined with the dominance of the informal sector, poses significant hurdles. Additionally, the country struggles with insufficient recycling infrastructure and gaps in policy implementation and enforcement. E-waste management in India faces significant challenges due to various structural and operational gaps. Lack of awareness among consumers and producers about the hazards of improper e-waste disposal remains a major concern. Many individuals sell obsolete electronics to informal recyclers without understanding environmental risks or legal obligations. The dominance of the informal sector exacerbates the issue, as most e-waste processing occurs in unregulated spaces with rudimentary methods like acid leaching and open burning. While the formal sector manages only 5% of India's e-waste, about 95% is handled informally, leading to toxic exposure and environmental damage. Insufficient infrastructure is another challenge. India has around 178 formal e-waste recycling facilities with a total capacity to process approximately 20% of the annual e-waste generated. However, these facilities remain underutilized due to weak collection mechanisms and fragmented supply chains. Lastly, the policy implementation gap hampers effective management. Despite progressive regulations like e-waste management rules 2016-2022, enforcement remains weak. Monitoring, financial incentives for producers, and stakeholder coordination need improvement for successful implementation. Addressing these challenges requires public awareness campaigns, strengthening formal recycling infrastructure, and integrating informal sector workers into regulated systems. Technological advancements play a significant role in improving e-waste management by enhancing recycling efficiency and resource recovery while reducing environmental impact. Innovations include AI-powered sorting systems, robotic automation, and advanced chemical processes such as hydrometallurgical and pyrometallurgical methods to recover valuable metals like gold, copper, and silver from discarded electronics. Additionally, mobile applications and digital platforms streamline e-waste collection, enabling better tracking and disposal processes. Urban mining techniques are gaining traction, promoting the extraction of reusable materials from e-waste, thus conserving resources and reducing landfill reliance. Despite these developments, India faces challenges in adopting such technologies due to high capital investments and the need for specialized technical expertise. The dominance of the informal sector and insufficient recycling infrastructure further hinder widespread adoption. Advanced technologies offer immense potential for scaling e-waste management, but their integration into India's system requires strong policy support, investments, and public-private collaborations. Leveraging these innovations can significantly improve India's e-waste recycling efficiency, making it more sustainable and resource efficient in the long term. However, addressing barriers like costs and skill gaps is essential to ensure successful implementation. As India approaches 2024, it faces both challenges and opportunities in e-waste management. The rapid increase in e-waste volume will test the country's management capabilities. However, this also presents opportunities for job creation, resource recovery, and innovative business models in the recycling sector. By 2024, India faces multiple challenges in managing its growing e-waste problem. The rapid increase in electronic waste, driven by technological advancements and higher device usage, is overwhelming the existing recycling infrastructure. The informal sector dominates e-waste handling, managing nearly 95% of the total e-waste, but often using unsafe and environmentally damaging methods like open burning and acid leaching. integrating informal workers into the formal system remains a major challenge due to policy gaps and socio-economic barriers. The adoption of advanced recycling technologies is hampered by high costs and limited investments, particularly in the formal sector, which currently handles only a fraction of the e-waste. The lack of adequate collection centers and resource recovery facilities exacerbates the problem. Ensuring compliance with e-waste regulations across diverse regions in India is difficult due to regional disparities, insufficient enforcement, and varying levels of awareness. Equally, by 2024, the e-waste sector holds significant potential for growth, offering opportunities for job creation, material recovery, and circular economy development. The formal recycling industry is expected to see increased employment driven by the rising demand for specialized e-waste management and recycling facilities. Recovery of valuable materials such as gold, copper, and rare earth elements from discarded electronics will play a key role in reducing the reliance on mining. Moreover, the development of a circular economy is crucial as manufacturers and consumers embrace sustainable practices like recycling and reusing components. This shift presents opportunities for innovative startups to create solutions focused on efficient e-waste recycling technologies, such as advanced sorting systems and eco-friendly materials recovery. These trends can also promote partnerships between governments, private companies, and non-profit organizations to strengthen the infrastructure for sustainable e-waste management. Strengthening infrastructure, enhancing enforcement, and fostering public awareness are critical steps toward achieving effective e-waste management in India. Collaboration between policymakers, businesses, and informal sector workers will be essential to address these challenges. India's e-waste management landscape is expected to transform significantly by 2024, with notable progress in key areas. 1. Increased formal sector participation is anticipated, driven by government incentives and stricter regulations, which will help establish efficient collection, recycling, and disposal systems. This shift will reduce dependence on informal recycling practices, which are often unsafe and inefficient. 2. The stricter enforcement of extended producer responsibility (EPR) norms will compel manufacturers to take greater accountability for the life cycle of their products, ensuring proper recycling and disposal mechanisms. This will also encourage producers to design eco-friendly products with easier recyclability. 3. Technological integration is poised to revolutionize the sector. Advanced tools like AI-powered waste sorting, robotics, and blockchain-based tracking systems will enhance operational efficiency and transparency in e-waste management. These innovations will also facilitate material recovery and reduce environmental impact. 4. Public awareness is expected to grow through government campaigns, educational programs, and community initiatives encouraging responsible disposal practices. Awareness about the environmental and health hazards of improper e-waste handling will further empower individuals and businesses to make sustainable choices. In conclusion, by 2024, India's e-waste management scenario is expected to evolve significantly. With stricter regulations and growing awareness, the formal sector's participation is likely to increase. Technological advancements and better implementation of extended producer responsibility (EPR) will play crucial roles in shaping a more sustainable e-waste management ecosystem. Now we end the topic presentation and let us review what we have presented so far. We started with introduction to the topic e-waste, a growing challenge for waste management in India, and then narrated e-waste generation in India, the numbers with the brief breakup. Types of e-waste in India, and later describe composition and hazardous components. This is followed up narrating environmental and health impacts of improper e-waste management, and later a comparison done for formal versus informal sector in e-waste management. Besides, legal framework for e-waste management in India and explained the role of Extended Producer Responsibility, EPR, in implementation. Continuing the topic, Challenges in E-Waste Management in India were narrated with technological innovations in e-waste management and potential challenges and opportunities by 2024. At the end, the future outlook, e-waste management in India by 2024. Now I request the viewers to stay tuned before we dive to continuing with the topic on e-waste as battery waste management and challenges. Till then, I wish you to plan and enjoy the Christmas festival trip around the world.